Alright, so we talked about that we can view a relation as a set of ordered pairs, also as a graph, because a graph really is just a picture of a set of ordered pairs. We can also talk about a relation in the form of an equation. Alright, let's talk about why we can do it in the form of an equation. If I have an equation, let's say y is equal to x plus 5, then from previous classes we would see that we could make a table, plug in some values for x, and get out some values for y. So let's say that I choose an x value of 0 in my table. If I were to plug in an x value of 0, I would get y equals 0 plus 5, and that gives me y equals 5. What that gives me is an ordered pair. If an x value of 0 goes in, a y value of 5 comes out. And we could continue to do this by choosing x values, plugging it in into the equation in place of x, and simplifying and getting out a y value. In this way, we can generate as many ordered pairs for that relation as we wish. So we can visualize a relation in the form of an equation because an equation represents a formula that you can use to find a bunch of ordered pairs. So when we're working with relations in the form of equations, and some of those relations turn out to be functions, we use something called function notation to represent those functions. So in this video, we're going to talk about something called function notation. So instead of writing y is equal to x plus 5, we replace the y with a new notation, f parentheses with an x inside. So we're going to replace the y with what we call f of x equals, and then the equation on the other side. So this is the new notation that we're going to use when we talk about a function in the form of an equation. Okay, we call this function notation. The letter f is the name of the function. So we can have different names. So here we have f of x, so this is function f. Here we have g of x, that's function g. So these two functions have different names. Here we have function m. All of these represent different names of different functions. If I said to look at equation m, then you know exactly which equation I'm talking about. So when we talk about function notation, we like to give our functions names. The letter that's in front of the parentheses represents the name. Okay, the x value that's inside tells us where the input goes. So when we put something into this equation, where do those numbers go? They're going to go in place of x. So x represents the places where the input is going to go into that equation. Now what comes out the other side? So what I get out as a result is the y value. Okay, so the result that comes out the other side is the y value. So the y represents the output of the function. Okay, so that's the basic idea of what we mean when we say function notation. Now, how do we actually use function notation in college algebra? So example 4 says to evaluate each function at the given value of the independent variable, and then we want to simplify. So our first part here, it says f, and then it has a parentheses, and then inside the parentheses is a -2. Okay, so first of all, the f is the name of the function. That tells me which of these three functions that I'm going to use. So which of those three equations or functions am I going to look at? So the f, I'm going to look at the equation f. I'm not going to look at equation g, and I'm not going to look at equation m. So the first thing is to look at the right function. Okay. The next thing is that the x value that's in the parentheses here is -2. So the number inside of the parentheses is what we're going to put in place of x in that equation f. So here's what I want you to do. I want you to go to equation f, and I want you to look at the right side of that equal sign. And I want you to copy down everything except for the x, and in place of the x, I want you to put parentheses. So when you see -2 times x plus 1, I want you to write -2 times parentheses plus 1. Okay, so that's the first step, and that's really important. The next step, I want you to copy what you had above, And now, inside of the parentheses, whatever you have on the parentheses on the left side of that equal sign, I want you to drop into the parentheses on the right side of the equal sign. So I'm going to put into the parentheses on the right side a -2. That is where the college algebra part ends. The next thing that I want you to do is to simplify just what's on the right-hand side of that equal sign. In order to do that, we use order of operations. So you've heard of PEMDAS, hopefully. So PEMDAS says to do what's inside of the parentheses first. Well, when I look inside of the parentheses, there's nothing to do. The next thing says to look for any exponents. I don't see any exponents. So the next thing is any multiplication or division that we see. So I do see some multiplication. I have to do that next. I have to do multiplication and division before I can do any addition or subtraction. Addition or subtraction comes last. -2 times -2, do that multiplication first. That gives me a +4. 4 plus 1 gives me a +5. This is the y value that comes out the other side. So this is the x value that goes into that equation, or that function, and this is the y value that comes out as a result. So we typically write our answer with all three pieces. We have the name of the function, so that tells us which of those equations we use to plug into. We have the x value that we plugged into that equation, or that function. And then we also now have equals. We have the y value that comes out as a result on the other side of the equal sign. So f of x equals y. We have f of -2. That gives us out a y value of 5. Another thing that I would encourage you to do is to use Desmos. So if you go onto a web browser, we have desmos.com. It's called Desmos. And that gives you an online graphing calculator for free, which is really nice. So if you were looking at -2 times -2 plus 1 and you really weren't sure what that was going to be, the calculator will actually do all of the order of operations for you. So we can type into this calculator using the keyboard. So I can type in -2 parentheses. You can put -2 inside, and then on the outside of that, +1. And so it tells me that that simplifies to be a +5. Okay, you are welcome to use Desmos. I highly encourage you to plug values into Desmos and let Desmos do a lot of the order of operation work for you. Okay, so you're welcome to do that. Okay, let's look at our next example. We have g of 4. Okay, so this is really significant. G of 4. Okay, the name of the function is g. That means that I am not looking at function f. I am not going to plug a 4 into function f. If you plug a 4 into function f, that tells me that you don't know what function notation is saying. I am not going to use equation m. Okay, so really important that you know, what does this information mean? So this means that I'm using equation g only. Okay, so not equation m, no other equation I see, I'm only going to use equation g. Alright, so once I know what equation I'm using, I'm going to look inside of the parentheses, and I see that I am plugging into the parentheses a +4. So where the x is, I am going to, instead of x, put a +4. Now what I want you to do is I want you to think about that equation as kind of an empty function, or an empty equation, and I want you to replace x with parentheses. So negative x parentheses squared, put a square on the parentheses. Okay, so I want you to see what I'm doing, and I want you to practice replacing all of the x's with parentheses. Turns out to be really important that you can practice doing that. Negative, and then x parentheses plus 3. Okay, so that is a really important step to me that could make a really good test question or a homework question. Okay. All right. Now, in place of that parentheses, inside, I am going to put whatever's in the parentheses on the left is going to be dropped into the parentheses on the right. So I'm going to put that +4 there. Now, I'm going to type this into Desmos exactly as I see it. And once again, I highly encourage you to do that. All right, close that out. So I'm going to type negative parentheses So the negative goes in front of the parentheses. Type in the 4. Now if I want to square something, I can use this a with a square. That's going to put that square on that parentheses. Then minus, parentheses, put the 4 inside, come to the outside of the parentheses, and then put plus 3. So that tells me that all of this simplifies to be negative 17. Okay, so our final answer would be g of 4 is equal to negative 17. So that means I used equation g to find this information. What did I put into equation g for x? Well, that was a positive 4. What came out the other side as a y value result is negative 17. Now for these next two examples, things get a little more interesting. Okay, so we have f of x plus 3. Alright, first of all, I want you to do this. What equation are we using? What's the name of that function? Well, that's function f, so that means I'm going here. Remember, that means I'm not using equation g and I'm not using equation m. Only equation f. Okay. What's going inside of this function is x. Now down here I have x plus 3 as the input. We'll come back to that in just a minute. Okay. Now what I want you to do as your first step is to write equals just like we did here. Okay, when we put negative 2 into function f, the first step was to go to the right hand side of the equal sign and copy everything you have. So negative 2, x. When you get to x, I want you to put parentheses. Okay, and then plus 1. That's a really important, really crucial step. Okay, you need to practice doing that. The next line, I want you to write exactly the same thing. Copy that down. And then I want you to go to the parentheses on the left side of that equal sign, and whatever's in the parentheses on the left side of the equal sign, I want you to drop into the right side of the equal sign. So I want you to drop into all the parentheses on the right of the equal sign. So if x plus 3 is over here as the input, I want you to write x plus 3 over here in the parentheses as the input. Okay, now that's where the college algebra part ends. The next part is simplifying using PEMDAS. Okay, so do what's in the parentheses first. I can't add x plus 3. Do I have any exponents? No. How about multiplication and division? Yes, I do have multiplication, so let's perform that. That's doing a distribution. Negative 2 times x, so that's negative 2x. I'm just going to scroll down a little bit here. Alright, so that's negative 2x, and then negative 2 times the second term in that parentheses, that positive 3. So negative 2 distributed to a positive 3, that gives me a negative 6. Now the negative 2 only distributes and multiplies times what's inside of the parentheses. The positive 1 is not inside of the parentheses, so it just comes on down. Alright, now we're going to combine any like terms. So negative 2x doesn't have any like terms, but negative 6 and positive 1 can be combined. Now if you're not sure what that is, you can always put that into Desmos. Negative 6 plus 1, that's a negative 5. So our final answer here is f of x plus 3 turns out to be negative 2x minus 5. Okay, so that's our final answer. Something that you're going to see. If you have a variable input, you typically, about 95% of the time, variable in, variable out. So you'll notice that we put something with x in, we got something with x out. The first two examples, we put numbers in. Number in, number out. Number in, number out. Variables in, variables out. That's very typical. Alright, what about g of negative 2a? Okay, so how do we tackle these types of problems? Now, I want you to do the first step every single time. Which equation are we using? Well, we're using equation g. And I want you to think about how we did equation g with a positive 4. Okay, the first thing we did is we went to equation g and we replaced all of the x's with parentheses. This step becomes even more important when you're putting in something other than just a number. If you're putting in some variables, this step becomes super important. So the first thing I want you to do is I want you to say, okay, which equation am I using? Okay, great. We're using equation G, and I want you to go to equation G and I want you to start reading it off. Negative, okay, negative, x. As soon as you say x, I want you to put parentheses right away. What's happening to that x is it's being squared, so put a square. Okay, and then keep going, negative, okay, copy down a negative. You see x, put parentheses, and then plus 3. You'll notice that this step and this step are exactly the same. So it doesn't really matter what you're putting inside of G. The first step for putting anything inside of G is to write out that function without the x's, but putting parentheses where x used to be. Okay, what's our next step? We'll copy that down. Okay, you want to make sure you practice that. It might take some practice, but you can do it. What are we putting inside? Well, we're going to go to what's on the parentheses on the left side of the equal sign, and we're going to drop that into all of the parentheses that are on the right side of the equal sign. So I'm going to put a negative 2a and a negative 2a. Okay, now we're going to practice simplifying this. Because it has the variables, we're going to practice simplifying this by hand. We still use order of operations, PEMDAS. Is there anything that you can do within the parentheses? So I have negative 2 times a, nothing there, negative 2 times a, nothing I can do there. Do we have any exponents? So this time we actually do have an exponent. So we're going to square what's inside of the parentheses. Now what does it mean to square something inside of the parentheses? I'm going to come up here, just rewrite this. Squaring means to write what's inside of the parentheses twice. So side by side, and then multiply that times itself. What's a negative 2 times a negative 2? Well, that's a positive 4. So I got that, positive 4. What is a times a? Well, a times a, we can only write that as a squared. There's two a's multiplied together. We don't know what the number of a is. We have to write a squared. So negative 2a times a negative 2a gives me overall a positive 4, and then a times a is a squared. Now that answer for that, okay, so when we took that and we squared it, that entire answer goes here. Notice that the negative that was outside, out front of the parentheses, is still sitting there outside, out front of that result of that squaring. Okay, so the negatives here, just carries on down. The squaring only applies to what's inside the parentheses. If you need to, you can go to the side, write down that parentheses squared, write it by itself, multiply that out, put that answer back in behind the minus sign. Okay. So there's our exponent step. Now, multiplication and division. Do I have any multiplication or division? In a way, yes. In a way, no. You can consider this to be like a negative 1, if you want to, times a negative 2a. That might make things a little bit easier. What's a negative 1 times a negative 2? That gives me a positive 2, and then I have the a. So negative 1 times a negative 2a, that's a positive 2a. Bring down the 3. Got that. Is there any adding or subtracting I can do? Now this becomes really important, okay? You gotta brush up on your algebra skills. These are not like terms. You cannot add those terms. They're not like terms. In order for terms to be combined, so in order for you to add or subtract things, they have to have exactly the same variable portion. So if this term has a squared and this term has a, then those are not like terms. They do not have exactly the same variable portion. When it comes to the adding or subtracting step, in order to combine terms or add or subtract things, they have to be like terms, meaning they have to have exactly the same variable portion. This is also not a like term because it has no variable at all. So these three terms cannot be combined. So that's actually as good as it gets. So g of negative 2a is negative 4a squared plus 2a plus 3. That is our final answer, and that is actually as good as it gets. So make sure you're careful with your algebra. Make sure you know your order of operations. Okay. So we wrote it out as an empty function. We plugged in the negative 2a to all the parentheses. After that, after we plug in that value, the rest of this is simplifying using your order of operations. College algebra part ends here. Everything else is that algebra class that you took before. Okay, practicing those algebra steps. Okay. All right, so our next two examples are using equation M. Remember what that means. So that means that I'm not using equation F this time. I'm not using equation G. I've seen some people plug that value into all three equations, okay? If you do that, that says I really don't understand what function notation is. And that's what I'm testing you on. Do you understand function notation? So if I say m of -1, what does that mean? Right? That's what I'm asking you. Okay. So we're using equation M. Okay, that's the name of our function. We're going to copy down equation M. Okay, and I'm going to scoot up a little bit so we can see it. That's 4x minus 5 divided by x minus 9. And remember, what I'm going to do, first step, is to replace anything that I see, anywhere that I see an x, I'm going to put parentheses instead. So I'm going to write 4 times x, that's 4 times parentheses minus 5. Okay, so that's what goes at the top. So that's the 4 parentheses minus 5, and then divided by parentheses minus 9. Okay, that's the first step. The second step is to copy down that empty function. So all those empty parentheses, I just want you to copy that down to the next step. Okay, so what goes inside all of those parentheses? Well, whatever's in the parentheses on the left side of that equal sign, that's where we're going to drop into all the parentheses on the right side of that equal sign. So I'm going to drop in a -1. Okay, so once again, we're going to follow order of operations. When I have a fraction, I have to actually do the top and the bottom separately. So I'm going to figure out what's at the top first. That's 4 times -1 minus 5. We are going to do the multiplication first. So that's -4 minus 5. Okay, now -4 minus 5 gives me a -9. So adding and subtracting comes last. Okay, so we're still using PEMDAS. Okay, simplifying at the top there, we did multiplication first, and then we did adding and subtracting. Okay, so -4 minus 5 is -9. If you didn't know that, you can use Desmos. -4 minus 5, -9. What about the bottom? -1 minus 9. Okay, there's no multiplication to do there. That's subtraction. -1 minus 9. So we just have to do our subtraction there. Put that into Desmos if you need to, but that's a -10. Now, a negative divided by a negative, we always simplify that to be a positive. So it's an overall a positive fraction, positive result. Okay, so I'm going to write this as m of -1 equals our final answer, positive 9/10. Now, there is a question there in your notes, and I'm going to actually, for now, skip that question. We might come back to that another time, but for now, we'll just skip over that. All right, so let's come to our next example. Our next example is once again using equation M. So I'm going to go to equation M. Now, I'm not going to bounce back up to the top. If you have the notes printed out, you can look back at the top. But we actually have equation M right here, right? We have the empty equation M. So everywhere we had an x, we put parentheses. So I'm just going to use what I've already done for step 1 of the previous problem, since it's using the same function. 4 times x minus 5, that's 4 times parentheses minus 5, divided by x minus 9, well, we put parentheses minus 9. Okay, so there's step number 1 of function notation. I'm going to copy what I have there as I move on to step number 2. Okay, step number 2 says now we want to say, well, what are we going to put inside of those empty parentheses? Well, whatever's inside of the parentheses on the left side, that's what I'm going to drop into the parentheses on the right side. So this time I have a plus h. So I'm going to copy a plus h into the parentheses on the right-hand side of our equal sign. I'm going to simplify as much as I can, once again, top and the bottom separately, and I'm going to use PEMDAS. So parentheses, exponents, multiplication, division, addition, and subtraction last. So at the top, we're going to start at the top there, we have a distribution. That's basically multiplication, but the 4 needs to be multiplied times every term inside of the parentheses. So that's 4 times a, or 4a, and then 4 times a positive h, which is 4h. The negative 5 is not inside the parentheses, so I do not multiply the 4 to the negative 5. The negative 5 that's outside the parentheses is just going to come on down to be part of the top of that fraction. Okay, so there's the top. Now, can I add or subtract any of those terms? So I actually cannot add or subtract anything there, because in order to combine things, combine like terms, I have to have exactly the same variable portion on each term that I combine. This one has an a, this one does not have an a, this one does not have an a. So there's no like terms to that first term. This one has a variable h, the others do not have the variable h. This one doesn't have a variable at all, but these do. So there's no like terms at the top, there's nothing I can add or subtract there. Okay, so let's go to the bottom. Now I have a plus h, parentheses, minus 9. That is not a multiplication, that is a subtraction. Okay, so be careful there. There's a minus sign in between, those are not being multiplied. Now if you want to think about a multiplication, you could think about a positive 1 kind of implied in front of that parentheses. But if I multiply in or distribute a positive 1, I just get a and h, right? So 1 times a is a, 1 times h is h. So nothing changes. Subtracting a 9, once again, I have no like terms at the bottom to combine. This one has a variable a, the others do not. This one has the variable h, the others do not. This one doesn't have a variable at all, and the others do. So there's nothing I can do at the top or the bottom to add or subtract. So it turns out that that is my final answer. Okay, so you might have to work on your algebra skills, what you're allowed to do, what you're not allowed to do. Work on using order of operations in PEMDAS as you simplify using function notation. Let's do some more examples of function notation. So we have f of negative 2. That means I'm using function f. So the first thing that I want you to do is go to equation f, and on the right side of the equal sign I want you to start reading things off. X squared. When you say x, I want you to put parentheses. So parentheses squared. Minus 2 times x, minus 2 times parentheses, plus 1, plus 1. The second step, I want you to copy exactly what you just wrote. Really important that you can practice that step. Every time you said x, you write down parentheses. Alright, so now what are we going to put inside of the parentheses? Whatever's in the parentheses on the left side, that's what's going to get dropped into the parentheses on the right side. So we're going to put in a negative 2. Alright, so there's the college algebra. Okay. What comes next, the simplification, I want you to simplify this, is your pre-algebra skills. Alright, so if you have only numbers in your problem, one really easy way to simplify here is just to go to Desmos. So I'm going to encourage you to do that. So I have parentheses, and inside of the parentheses I have a negative 2. I'm going to come outside of the parentheses, and then I'm going to find the button that represents squaring. So a squared here. So there we go. And then I'm going to do minus 2, parentheses, negative 2. And I'm going to come outside of the parentheses, really important. That plus 1 is outside of the parentheses, so make sure you click outside and push plus 1. That gives me a positive 9. Okay, you're welcome to use Desmos when you can. Alright, so our final answer, we're going to write f of negative 2 is equal to a positive 9 as a result. Okay. G of negative 3. First thing I want you to think about is, what does G mean? G means to look at this equation only. Remember, if you take a negative 3 and plug it into all 4 and give me 4 different answers, that says I do not understand function notation. So make sure that you understand G there means only look at equation G. And the first step that I want you to do is to read the equation that comes on the other side of the equal sign, and every time that you say x, I want you to put parentheses. So x to the power of 4, parentheses to the power of 4, plus x squared. So plus parentheses squared, plus 3, plus 3. I want you to do that step, and I want you to write down exactly that same thing, copy it down. Okay, this could make a really good test question. All right, now what are we putting inside of those parentheses? Whatever's in the parentheses on the left-hand side is what gets dropped into the parentheses on the right-hand side. So I have -3, -3. Now we're going to simplify that using order of operations. Okay, since there's only numbers in this problem, we can use Desmos to simplify that. So I'm going to pull up Desmos. I'm going to X out of that. I'm going to type exactly what I see here. So parentheses, -3. Come outside of the parentheses, we want to raise that to the power of 4. Now we're not going to hit this button again because this is only going to raise things to the power of 2. I'm going to go to the button that's right beside it that says a to the power of b. So when I hit that button, it basically gives me a chance to type in whatever I want for the exponent. So I type in 4. Now you'll notice that the line is still blinking up there next to the 4. If I type in this and keep typing, it's going to keep adding to that exponent. And we don't want that. So we're going to come down to these arrows, and I'm going to hit the arrow, and you'll notice that that blinking line now is a big regular line. And I want to hit plus. I want to make sure I'm outside of the exponent now, a big regular plus, parentheses again, put the -3 inside, come outside of the parentheses. This time I want to square the parentheses. So I can just hit this button right here. Okay, now my cursor is big, so that's good. Then I want to hit plus 3. Okay, so what's nice here is Desmos will do all of that work for you if all you have are numbers in the problem. So our final answer there is -3. Okay, so I'm going to write g of -3 gave us a result of a y value of 93. Okay, so things start to get a little bit more interesting again when we start to put in variables, right? We said number in, number out. So both of these first examples are number in, number out. Number in, number out. Okay, not too bad. These next two examples, we're putting in variables, so variable in, variable out. Okay, so this is f of x plus 3. Once again, I want you to think about what that f means. The f means only to look at equation f. And we're going to do the same first step. Everywhere I have an x, I'm going to put parentheses. X squared, parentheses, squared. Minus 2 times x, that's minus 2 times parentheses, plus 1. So copy that down as an empty function. That's the first step. The second step, copy down what you have there, but this time, whatever we have inside of the parentheses on the left, now we're going to drop those into the parentheses on the right. Alright, I have x plus 3 squared minus 2 times x plus 3 plus 1. Okay, we're going to simplify using PEMDAS. Okay, since we have some variables in the mix, I'm going to practice doing this by hand. Alright, so x plus 3 squared. That is an exponent. There's nothing that we can do within the parentheses, so I'm going to skip that. But we do have an exponent. This is really important, this step right here. Okay, what does it mean to write x plus 3 squared? Okay, some people would write that as x squared plus 9. Okay, so there are some people watching this video right now that will do that. Okay, if you're one of those people, then you need to make sure you're paying attention right now because that is incorrect. What does it mean to square something? To square something means to multiply that thing times itself. So x plus 3 squared is actually x plus 3 times x plus 3. Now how do I multiply two terms times two terms, or a binomial times a binomial? Remember FOIL? So write it out twice in FOIL. First times the first, x squared. Outer times the outer, 3x. Inner times the inner, 3x again. Last times last, plus 9. Okay, so really important, when you have a group like that in parentheses, those two terms squared, write it out twice in FOIL. Okay, so there's the exponent. What about multiplication and division? I do have some multiplication because I have -2 times x plus 3. So I can distribute there. So give me -2x minus 6. The plus 1, remember, just comes on down. Now we're going to combine like terms and make things look as nice as we can. Now, to combine like terms, when you get to that adding and subtracting stage, in order to combine things, these terms have to have exactly the same variable portion. X squared, there's only one of those. There's no other term that has an x squared. So that just comes on down. Now, what about 3x? Does that have a like term? Are there any other x's? Yes, we have another 3x. Are there any other x's? Yeah, we have a -2x. So I can combine all of those. Those are all like terms. So 3 plus 3 is 6, minus 2x, that's a positive 4x. So when I combine all of those like terms, I keep exactly the same variable portion. So if they all have the same variable portion, combine the numbers in front, keep that same variable portion. Okay, anything else can be combined? Well, I have a positive 9. That has no variables in that term. Is there anything else that has no variables? Yeah, we have a -6 and a positive 1. Okay, 9 minus 6 is a positive 3, plus 1, it's a positive 4. Okay, so make sure when you get to that adding and subtracting stage that you understand how to combine like terms. Okay, so our final answer here will be f of x plus 3 is equal to x squared plus 4x plus 4. Nothing else that you would need to do. We just wanted to plug in that x plus 3. That's where the college algebra ends, but then we want to practice that pre-algebra skill of being able to simplify using order of operations. Alright, so let's come over here. What about g of -2a? Okay, so g. That means I'm looking only at equation g. We're going to copy that down again. What's on the right side of the equal sign is x to the power of 4. So that's parentheses to the power of 4. Plus x squared. So that's plus parentheses squared plus 3. I'm going to copy that down exactly as I have it. Okay, there we go. Now, what are we putting inside of the parentheses? Whatever I have in the parentheses on the left is what I'm going to drop into the parentheses on the right. Alright, so there's where the college algebra part actually ends. That's the new thing for college algebra. The rest of this is going to be your algebra skills. So you're kind of your pre-college algebra skills of working with order of operations. Okay, the first thing I have to do anything inside the parentheses. Really nothing I can do inside because -2a, there's really nothing that can happen there. Do I have any exponents? Yes, I do. Now you have to pay careful attention to what I'm doing here. Remember that -2a is what's in the parentheses and it's raised to the power of 4. That means that I have to multiply that times itself 4 times. So pay careful attention here. This is going to pop up in your homework. When you write that out 4 times, we're going to multiply all of the numbers together first. What is a -2 times a -2 times a -2 times a -2? Okay, well, -2 times a -2 is a positive 4. And then we do that again, we get another positive 4. Okay, a negative times a negative is a positive. And here we get the same thing. Now, we're multiplying all 4 of these numbers together. If I multiply these two together and these two together, I still have to multiply those two together. Positive 4 times positive 4 gives me a positive 16. So I get a 16. Now, be careful here. Okay. We have an a, and then I have another a, times another a, times another a. That's a. That's A times A times A times A. Some people are tempted right now to say the answer is just A. Okay, but that doesn't make any sense. How do we have 4 A's over here, and then it becomes 1 A over here? Right? So that doesn't make any sense. If you have 4 A's multiplied together, there's 1 A, 1 A, 1 A, 1 A. How many A's total am I multiplying together? When we have multiplication of the same thing repeatedly, we use exponents to represent how many times we're multiplying A times itself. So we're going to put A to the power of 4. Okay, so that represents how many A's are left being multiplied together. A to the power of 4. So really important. Practice that. All right, what about negative 2 times A to the power of 2? How do I square that, right? So I'm still in my exponent phase, okay, because I still have this exponent here. Okay, so negative 2A times negative 2A. Negative 2 times negative 2, that's a positive 4. A times A, it's A squared. So that's plus, then behind that plus, we're going to write that squaring. Bring down the plus 3. Now I have multiplication and division. Well, there's no multiplying going on, no division going on. So our last phase is adding and subtracting. Are there any like terms that I can combine? Be careful here. Sometimes people think they can combine those two terms. But remember, in order to do the adding and subtracting phase, you have to have like terms. Like terms means that you have exactly the same variables and exactly the same exponents on those variables. Now they both have A's, but one has A to the power of 4 and one has A squared. These are not like terms. You cannot combine them. Okay, so that means that the best that we can do is actually to stop right there. Our final answer is G of negative 2A is equal to 16A to the power of 4 plus 4 times A squared plus 3. So that's as good as it gets. No adding and subtracting can be accomplished. All right, so that's our final answer. Make sure you're practicing these ideas here. All right, so our next example says to find m of negative 12. Okay, so to figure out m of negative 12, I need to find equation m. So I'm going to go up to the top here. I have 4 equations to choose from, but we know that we're going to skip over everything that doesn't have an m. So this time it says m of r. It doesn't really matter what the variable is that's used in the equation. We're going to treat it the same way every single time. So we're going to treat r here the same way that we treated x. So our equation, m of r is equal to the square root 4 minus r. And so that part is the only part that's underneath the square root. And then outside of the square root, this part is not underneath that bar. The bar stops there. We're going to say subtract 5. All right, so we're going to copy that down. Remember, what we're going to do is everywhere we say r, okay, everywhere we have that variable, we're going to replace it with parentheses. Okay, so that's what I'm going to refer back to. So I'm going to scoot down. All right, so that is the square root 4 minus r, parentheses, and on the outside of that minus 5. So square root 4 minus r, we're going to put parentheses in place of the r, then our minus 5. Okay, now what do we drop into those parentheses? Okay, whatever's in the parentheses on the left, that's what we're going to drop into the parentheses on the right. So we're going to put in a negative 12. When you have square roots, you have to simplify what's underneath the square root first. So 4 minus a minus 12, well, 2 negatives give us a positive. 4 plus 12 is 16. The square root of 16 is a positive 4. We'll bring down the minus 5, that's outside of the square root. And the last thing that we're going to do is 4 minus 5. 4 minus 5 gives us a negative 1. So m of negative 12 simplifies to give us a negative 1. All right, so our next function notation is also using equation m, and we're putting inside of that function 4 minus 3x. All right, so the first thing that we're going to do is we are going to write m as an empty function. So we already have that here. So the first step for m of negative 12 was to replace the variable with parentheses. So I'm just going to actually copy the work that we've already done. So that's 4 minus r, parentheses, and then outside of that minus 5. Okay, I'm going to copy exactly what I have there. Okay, now what are we putting inside of the parentheses? Okay, whatever's in the parentheses on the left, that's what I'm going to put into the parentheses on the right. So that's 4 minus 3x. Okay, after that we're just simplifying. So there's the college algebra part, but we do need to work on our simplification skills. We have to simplify what's underneath the square root first. The negative would get distributed into the parentheses. So that's 4, and then minus a 4, and then a negative times a negative 3x is a positive 3x. Okay, we're going to continue to simplify what's underneath the square root first. Can we combine any like terms? I have a positive 4 and I have a negative 4. Those do not have variables, so we can combine those. 4 minus 4, those actually cancel out and give me 0. So really the only thing I have left underneath my square root is a positive 3x. Okay, well on the outside of our square root we can bring down our minus 5, and that's actually as good as that gets. We can't take the square root of 3x. We don't know what x is. So the square root of 3x is as good as it gets underneath. And because we couldn't simplify what's underneath the square root and the square root is still there, then we cannot combine that with the negative 5. So our final answer is m of 4 minus 3x is equal to square root of 3x minus 5. Alright, so our last two examples of function notation are h of 2 and h of negative x. Both of these are using the same function h. So let's go up to the top and see what is equation h. So h of x is equal to, we have 8 times x cubed plus 1 divided by x cubed. One thing I'm going to mention here is that we know from our pre-algebra days that we are not allowed to cancel out the x cubes. The equation that we have here is already simplified as far as canceling common factors. So we do not need to cancel, and in fact we are not allowed to cancel. So don't do that. 8x cubed plus 1 divided by x cubed. That's as good as that gets, and we're just going to plug into exactly that. So I'm going to copy that down. In place of x, I'm going to put parentheses. Alright, so that's 8 times x cubed, parentheses cubed, plus 1 divided by x cubed. Okay, so that's step 1. Step 2 is to copy. Alright, so what am I going to put inside of those parentheses? Okay, so everywhere I have an empty parentheses, we're going to put in whatever we have on the parentheses on the left is going to go into all those parentheses on the right side of the equal sign. So I'm going to put a 2 here and here. And remember that we simplify the top and the bottom separately. Alright, so we have to do order of operations at the top, PEMDAS. Okay, there's nothing to do within the parentheses at the top. I do have an exponent though. Okay, what is 2 cubed? That's 2 times 2 times 2. If I write that 2 out 3 times, multiply times itself, I get 8. Okay, so that part gives me 8. Okay, so there's the exponents. Do I have any multiplication at the top? Yes, I do. 8 times 8 gives me 64. So now I have 64 plus 1, and that brings us to the adding and subtracting phase. And we are allowed to add 64 plus 1, we get 65. So there's the top of that fraction simplified as much as we can. Okay, now we simplify the bottom. 2 cubed. Well, that's 2 times 2 times 2, which gives me 8. So that was a pretty quick simplification. Now, there's nothing more that we can do there. We're just going to leave that as a fraction. So our final answer is h of 2 is equal to 65 divided by 8. There's no common factors between 65 and 8, so I'm going to leave it exactly like that as a simplified fraction. All right, now we have h of negative x. The first step for h of 2 is exactly the same as the first step for h of negative x. We would copy down that function, replacing the variable with parentheses. So that's the same step that we would use for h of negative x. So I'm just going to copy down basically the same thing over here. Now, what am I putting inside of these parentheses this time? Well, I have to put in whatever's in the parentheses on the left. So that's negative x this time. All right, we're going to simplify using PEMDAS again. Nothing I can do within the parentheses, but I can do the exponent. So I'm going to come to the side and write negative x times negative x times negative x. So negative x, I'm going to copy down that parentheses 3 times because of the exponent. A negative times a negative times a negative is a negative, right? Now x times x times x. Doesn't make any sense to write x, and that's it. If I have 3 x's, how do 3 x's become 1? Or that doesn't make any sense. We have an x here, I have an x times itself 3 times, so I'm going to put a 3 to say that's x cubed. Okay, so we have 8 times negative x cubed. Okay, so remember we're doing top and the bottom separately again. Okay, negative x cubed times 8. Now we're at the multiplication and dividing phase. What's 8 times negative x cubed? Well, the best that I can write that is negative 8 times x cubed. Negative times a positive gives me a negative overall answer. And I cannot add or subtract because they're not like terms. This one has an x cubed and this term does not. So I cannot get like a negative 7 or anything. Okay, that's as good as it gets. I cannot combine those. Those are not like terms. Okay, so be careful there. Okay, so what about the bottom? Negative x cubed. Well, we already figured that out. That's negative x cubed. Copy that down. There's no multiplying, there's no adding and subtracting to do at the bottom, so this is actually as good as it gets. H of negative x, the final answer is a fraction, variable in, variable out, negative 8x cubed plus 1 at the top, all of that divided by negative x cubed. And that is as good as it gets. Don't touch it, leave it alone. We are done.